Okay, so I decided I wanted to do one Le Chatelier's problem for you just to make sure you were comfortable with it. So we have this equilibrium equation, and notice that it is a heterogeneous equilibrium, meaning it has a solid here. So the first thing I ask you is, what if we remove or add some solid? And if you remember from class today, we talked about how removing or adding solid or anything solid or liquid doesn't affect an equilibrium at all. And that is because when we're looking at equilibrium, we're looking at concentrations, and we determine the concentration of a solid or a liquid by its density. So that's this over here. We have the density is the mass over volume, and if we use the molar mass, we can go to moles and get big M, molarity. So adding or removing solid has no effect on the density of the solid. Okay, so this is going to cause no change. Okay, then we said, what if we add some HF? So that's going to, if we think back to Q, we're increasing the reactance, so we're making the bottom bigger, which is going to make Q less than K. So Q is too small. So to fix it, we actually need more products. Okay, so we're going to shift to make more products. Here we have one with temperature. So we said that this reaction is exothermic. We're going to treat temperature as a substance in this equation. So if we increase the heat, it's going to shift away, just like increasing the UF4 would cause a shift away. Okay, we're not going to worry about calculating Q or anything like that. That's just one that you're going to learn for right now. You can look at it more in detail in the chapter if you want to. Okay, then we can change the pressure by adding a inert gas. Now this one is kind of interesting, but it actually has no effect on the equilibrium. And that is because it's going to change the total pressure because we're adding some particles. So it's going to contribute like a little bit to the pressure, but it's not going to change the individual pressures of the other substances. Those things are the same because we're not changing the amounts of the other substances. So adding an inert gas actually has no effect on an equilibrium. And the last change that I have down here is, what if we lower the pressure by increasing the volume? So to help you see this, I kind of made a little fake scenario. Let's pretend that the K for the system is 1. Okay, and that we have 1 mole over 1 liter, and we just get 1 as the K. Okay, now it said we're going to decrease the pressure by increasing the volume. So let's increase the volume to 2. Okay, so when we do that, let me move this up a little bit. We now have 1/2 to the second power, 1/2 to the first power, 1/2 to the fourth power. When you do these numbers out, you actually get 1/8 over 1/16. And from there, you're going to divide, and you're going to see that Q is equal to 2. So Q got bigger. So when we talk about a shift by changing the pressure, okay, we like to say it shifts away or toward the side with the least number of moles. Hopefully by looking at the Q, you guys can actually see here that the reason it has to do with the moles is because the moles show up in the equation as these exponents, okay, and we saw how the numbers worked out. Here we need to shift towards the side with more numbers of moles because we decrease the volume. No, we decrease the pressure. If we were to increase the pressure, we shift towards the side with the least number of moles, so the opposite. Okay, I hope that helps a little bit with your thinking about Le Chatelier's, and have fun.